Systems of equations can be useful when we're solving an application problem with more than one unknown or more than one variable. So when we work with application systems problems, we kind of have three steps. We're going to define our variables. If you always want to use X and Y, that's fine. If you want to use letters that represent specifically what we're talking about, that's fine. Second thing we're going to do is we're going to write two equations. Since we have two variables, we need two equations. Third step we're going to do is we're just going to solve it. We're going to choose which method we think works best. Probably not graphing on these. We're probably going to use substitution or elimination. So we're going to see which method we think looks easiest and solve using that. Okay, so let's do those three steps on example 186. If we read through this problem, in a child's bank are 11 coins. I'm going to underline things that are important. 11 coins that have a value of $1.85. The coins are either quarters or dimes. And what we're trying to find is how many of each coin this child has. So how many are quarters, how many are dimes? So the first thing we're going to do is define our variables, define our unknowns. We do not know how many quarters and we do not know how many dimes. That's what we're looking for. So I'm going to let Q represent quarters, and I'm going to let D represent dimes. The number of quarters in this bank, the number of dimes in this bank. Okay, so now we're going to use those variables and we're going to write two equations. We have two unknowns, we need two equations. So we're going to use the fact that there's 11 coins total to help us write our first equation. If we know we have 11 coins total, some of them are quarters, some of them are dimes, we know that if we add up how many quarters we have plus how many dimes we have, it's going to total 11. That's our first equation. Okay, our second equation, it says it has a value of $1.85. So we're going to write an equation using the value of each coin. So think about the value of a quarter. A quarter is worth 25 cents. So 0.25 times however many quarters we have, plus the value of a dime is 10 cents, plus 0.10 times however many dimes we have. We know that our total value is going to be $1.85. Okay, we're going to go ahead and solve this one together just so you're reminded of the process. But on the rest of these, we're just going to practice defining our variables and setting up the equations. And if you need a refresher of how to solve by substitution or elimination, you can use prior videos for that. Okay, so looking at this one, really this one's set up just fine for either substitution or elimination. I usually prefer elimination. So I'm going to choose to eliminate one of my variables, and I'm going to eliminate my dimes. So if this is a positive 0.10, I'm going to multiply this one by a negative 0.10, and I'm going to rewrite what we get when we do that. We get negative 0.10Q minus 0.10D equals 11 times negative 0.10 is negative 1.1. Okay, our second equation we didn't alter, so we keep that the same. 0.25Q plus 0.10D equals $1.85. Now we're ready to eliminate. Negative 0.10, positive 0.10 eliminates. If we combine our Q's, a negative 0.10Q plus 0.25Q gives me 0.15Q. Equals, if we combine our numbers on that right side, we should get 0.75. All right, we're ready to solve here. We divide by 0.15, and we end up that Q equals 5. That means that we have 5 quarters in this piggy bank. Okay, to find our other one, it's nice that we know the total number of coins, so we know that our 5 quarters plus however many dimes we have equals 11. If we subtract 5 from each side, that means that we have 11 minus 5, or 6 dimes. So in this piggy bank, we've got 5 quarters and 6 dimes. So really the only new thing here is defining your variables, setting up the system of equations. From there, you can solve using elimination or substitution, or if you're feeling super ambitious, you could solve by graphing if you wanted to. Okay, so let's practice setting up a few more problems. Example 187 says there were 41 tickets sold for an event. I'm going to highlight that right there. Tickets for children cost $1.50, and tickets for adults cost $2. Total receipts for the event were $73.50. And we're trying to answer how many of each type of ticket were sold. Okay, first thing is to define the unknowns, define what we're looking for here. The unknowns are how many children tickets were sold and how many adult tickets were sold. So you can use C and A, you can use X and Y. I'm going to go ahead and use matching variables. I'm going to use C for children tickets, A for adult tickets. So let's let C be the number of children tickets sold. And I'm going to let A be the number of adult tickets sold. All right, so we're going to use those variables to write two equations. The first one, we're going to use this fact right here, that we know 41 total tickets were sold. Some of them were adults, some of them were children. So we know if we add up our children tickets plus our adult tickets, they sold 41 tickets. All right, our second equation is going to be talking about the value of the tickets and how much money was collected. So each child ticket costs $1.50, so we can say 150C, plus each adult ticket was $2, so plus $2 times A, equals, it was a total of $73.50. Again, this one's set up where you could substitute or eliminate. If you wanted to substitute on this one, you would just need to get one of these variables alone, then plug it into this equation. If you wanted to eliminate on this one, we'd probably multiply our top equation by either negative 150 or negative 2, either way. Okay, a few more that we're going to practice setting up. Example 188 says a man has a collection of stamps made up of 5-cent stamps and 8-cent stamps. It tells us there are 3 times as many 8-cent stamps as there are 5-cent stamps. So we have more 8-cent stamps than 5-cent stamps. It tells us the total value of all the stamps is $3.48, and we're trying to answer how many of each kind this guy has. All right, let's start with defining our variables. We have two kinds of stamps. So I'm just going to use X and Y on this one. So I'm going to say let's let X be the number of 5-cent stamps. And I'm going to say let's let Y be the number of 8-cent stamps. So careful here whenever we write our first equation. In this case, they did not tell us the total number of stamps. They just said there's 3 times as many, this is key, 3 times as many 8-cent stamps as there are 5-cent stamps. So we know our 8-cent stamps, our Y, equals 3 times our 5-cent stamps. And then our second equation is going to be talking about the values. Don't forget how we write 5 cents here. We write that as 0.05, 8 cents is 0.08. So our second equation is going to say 0.05x plus 0.08y equals, it has a total value of 348. Okay, this specific problem is geared towards substitution. We already have our y isolated, so we could just substitute this in here for our y and solve for that. All right, and then our last one here, it says a total of $8,500 is invested. Part of it is invested at 6%, and the rest is invested at 3.5%. Tells us the total interest after 1 year is $385, and we want to know how much was invested at each rate. Okay, so our two unknowns are going to be how much money was invested at 6% and how much money was invested at 3.5%. So if we define those variables, I'm going to let x, I'm just going to use x and y again. let X be the money invested at the 6% interest rate, and I'm going to let Y represent the money that was invested at the 3.5% interest rate. Okay, so from here, our two equations, one of them is just going to be about how much money was invested total. If we add up how much was invested at 6% and 5%, we get $8,500. Okay, careful when we write percentages as decimals here. 6% is 0.06, 3.5% is 0.035. So we get 0.06x plus 0.035y equals, it said our total interest is $385. So here's our two equations. Again, this is geared, it doesn't really matter if you use substitution or elimination to solve this one. Okay, I'm going to go back through just in case you guys choose to finish solving these on your own and you want to check your answers. I'm going to go back through and write what you should get. So for this one we just talked about, you should get that they invested $3,500 at 6%. So that's my X. And then for my Y, we should get that they invested $5,000 at 3.5%. For the problem before, talking about the stamps, we should end up with, this guy has 12 5-cent stamps, and he has 36 8-cent stamps. And then the one about the children and adult tickets, we should get that there were 17 children tickets sold, and there were 24 adult tickets sold. So that's how, if we're given a situation problem with two unknowns, we can set up our system of equations.